Welcome back, everyone, and today we're going to do another video, and this one we're going to build the stamina wheel from Zelda. I've been really playing the game lately, and I'm really loving it, and I'm super inspired about a lot of its mechanics, and I kind of like the stamina wheel. Even though it's kind of annoying sometimes, it's an interesting mechanic of it. And We're going to build it. We're going to do the animations. We're going to actually have it actually really work. So it's more than just the visual effects of it. We're actually going to have an actual working stamina wheel. I was actually kind of inspired by it by another YouTuber from The Art of Code. I saw this video recently about polar coordinates, and he did an awesome job of illustrating how to convert UV coordinates into polar coordinates that allows you to then create shapes like circles and whatnot. So I actually ended up using some of his shader code to actually build it, like, because it works. It works beautifully. And like, if I want to build a stamina wheel, I need polar coordinates because it's circular. It makes things so much easier. So mad shout outs for him. I love the video. He's definitely worth it. I'm gonna put a link to this video. It'll explain all the code. There's not a lot to it. It's pretty simple. I don't want to go through it, to be honest, because like I said, he's the one who basically taught me. Go straight to the source. He deserves a lot of love. Definitely. So we got a stamina wheel, right? And maybe we'll just hold down the space bar, let go, and it's going to just heal. And if we want, we can just make it completely exhausted, let go, and it animates back, and then pop. Now it's completely full back that. So that's what we're going to be building today. All right, so let's look at some code. So we're going to have a new shader. I'm going to call it test stamina, and we're going to be using a quad to render it, and we're going to. It's a little hacky how I put it together, to be honest, but it gets the gist of how it should function. And I'm gonna have a class called Stamina, which kind of just deals with the mechanics of how it works, and deals with some of the animation states. And I just grab the shader out of the resources that we loaded in, because I want to be able to kind of control it manually. I'm doing something simple. I'm just grabbing some keyboard events so I can just know if I'm running, yes or no. Just very simple thing. So this I can hold down the spacebar and really test the stamina wheel. So let's get to it. So to do for me to do a stamina, I don't want to say in general. Quite a bit of information that I need to know. First, I want to know unit strength. And unit strength I'm using is how much strength does each wheel have. So our stamina wheel has 3 wheels. You have the center wheel, the second wheel, and the third wheel. So each wheel basically has the strength of 10. So I have a total of 30, which should be right here. Unit full. What's the value when I'm completely full? And it's unit strength times unit count. This whole object is built so you can have as many wheels as you want, but the shader is not designed that way. At some point down the line, if I do use it in like a game, I will probably program it where I can build maybe tons of wheels into it. But for right now, this works in the sense that you can have as many wheels as you want. The shader, only 3 wheels. So that's what I mean by unit strength. It's like, how much strength does a wheel have? So if I'm down to 5 units of strength, that means that's divided by that, it means half. That means I should only have half a wheel rendered. So it helps you figure out kind of like how much is left. So this way you can use the percentage, because I'm going to use a value between 0 and 1 to determine how much of a wheel is currently being used. And I'm actually using a whole value current. Right now, so it's set for 30. I should probably do this. Currently, it's full. It should be full. Like I said, I hard-coded 30 because I was working on it. Unit count is how many wheels. I keep using the unit because I don't want to call it a wheel because maybe I want to do diamonds. Maybe I want to do any weird shape in the future so I don't have to copy the wheel. So that's why I'm using the word unit. But anytime you see the word unit, you can just mentally change it to wheel. So it's wheel strength, wheel count, wheel small use, wheel heal rate, wheel use. Okay. So small use is how much how much stamina is used per second, because this is we're going to use stamina based on delta time. So this way the use is frame rate independent. So we're going to, like I said, it's going to be 5 units per second. So while you hold down the button, for every second that passes, you're going to use 5 units of strength. So that's how fast you drain it. Unit heal rate is when you let go of the spacebar and your wheel starts to regenerate. This is how fast it goes. It goes 10 units per second. So you kind of have to wait 3 seconds. Like if you completely exhaust all your stamina, it takes 3 seconds to rejuvenate yourself. Didn't have unit use. What the hell is unit use? Oh my god. Which am I using? I don't know what I'm using that one for, to be honest. I didn't comment this. Oh, okay. All right. That's right. This is just an angle value of how much the redness is. That's right. So when you see that part that right there, I think that tells me how big I want that wheel that fragment to be. So if I want that to be bigger, I can just say, change that to 1. And see now the part, I guess the part of the wheel that's being used currently is bigger. So that's just a visual thing, to be honest. It just visually show you how much you're currently using. I couldn't come up with a better name for it. I don't know. But this is an angle, so I'm just stating this as that's really an angle in radians. Screw it, I don't type it out. And full and state, and we have 2 states for this. Down the line, this probably needs more states to control a lot of different types of animations. But for right now, I have a ready state, and then I have an exhausted state. Once it's exhausted, that means you can't use stamina anymore until it's been rejuvenated completely and it's back to ready state. If I do this and let go, you're still in good. That means you rejuvenate, but you can keep doing this. I can just keep spamming my stamina, but if I were to drain it completely, you would then have to wait to be able to use it again. I'm sorry, I'm just got really dry throat today. So that's pretty much it. So we have a function that says small use because in the game there's like either small use or big use, like when you do a jump while climbing a mountain. That's why I kind of call it small use, and then it might have a different value for big use. This can be built in different ways where you just say use and you pass in the value of usage. That probably makes more sense. But for just prototyping, I didn't want to go through all that because you have to kind of calculate angles too a little bit. So it's just easier just to use these numbers, to be honest. So because I want to use time. That's the big thing. So I wanted this object to kind of handle. So I know what the unit that I want to change, but was based on time, which is delta time. So that times t minus that current, and that's it. If somehow current becomes less than 0, I'd say, hey, we're exhausted. I change the state current back to 0, and I say the state is exhausted. So this way, I think I use it later in another example of how to use that state a little bit. We have another function in here called rest. is does the same thing as use, but the exact opposite, based on time. And once the current rate is equal to or greater than full, it just sets it to full, just in case we go over it, and then changes the state back to full. So we're ready. So we're ready to rock and roll again. And then we have a function that ends up calculating the strength, and the strength is calculated. There's two things. There's the first array, which is how much the angle of, because everything here ends up being calculated to angles. So let me say, let's go back to the shader. Maybe I need to explain the shader a little bit before we deal with how do we get the information from it. So we're going to have a couple of uniforms you can pass. We have ring using and ring used. Ring used is basically the black part, the used up space. And using is the one that highlights, that animates, the red and orange animating one. Okay. So we're passing in those two different angles. So we're basically setting up the two angles that we want rendering to happen. We have a very simple vertex shader. We just do a little bit of time and UV. So this is how fast I want the blinking. I'm just using this for the blinking, really. So that time is just the blinking for the using. And then I have we've done this before. This is a spherical billboarding. So this way, no matter which direction I move the camera, it's always facing you. That's how it is in the game, I believe. So that's pretty standard of vertex shader. Then we have our fragment shader. So so I have a couple of things defined. I have some pies because I need pie values. I have some of the base colors. So the base color is green. Use color is that dark color. In use is the red, and in use fade color is orange. So it fades between these two colors. I pass in the 6 angles. Basically, it's the same, 2 angles per wheel. And then a state if you're healing or not. Because if it's healing, I don't want to use the base color. I want to use the in-use color. Cause that's when it's red, it's healing. It's resting or whatever. So this part is all from that YouTube video from the Art of Code. And like I said, there's not much to it, but all you have to do is take your UV coordinates, subtract 5, because you're moving the coordinates of the quad from. Let me see. Can I change something? Change it to this. Refresh. It's not working. Unless I gotta. There we go. See, there's our quad, right? So the UV coordinate starts here. So what we want to do is basically translate that UV coordinate to the center of the screen. So instead of 0, 0 being here, we want 0, 0 here. So that's what this kind of does. It just moves it. Now we have to convert the UV value to polar coordinates. So we get the length, and polar coordinates is just 2 things: angle and length. So the current pixel that we're rendering, what is its length from the center, and what is its angle based on the center. And then I have another one called normalize. So A10 gives you a value between pi and negative pi. Then I divide it by pi 2, which is 2 pi times 2, which then converts it to a value between 0 and 5. And then I do plus 5, which then converts it to value 0 and 1. So this way I can deal with angles with values just between 0 and 1. And that's why I said in here, these things deal with angles because I just pass in angles into the shader. So now that I know what angle and what length that the pixel that you're currently drawing, I just do some comparisons. I check to see the length. How far away from the center is it? If it's between this range, it's ring A. If it's range B, it's ring B, C, whatever. I just mess around with it until I got it to look just right. This is just ranges. It's just the length. So it's 0.12 is from the center to this part right here. Just to illustrate the idea. If the ring angle that I'm using is not equal 0, so this one I'm kind of currently using. So if I'm using the ring, if it's not 0, and the angle, and then it's another range check. If the angle is between these two values, the ring using and the ring use, this is the color I want that pixel to be drawn. This if statement sets up that blinking red line. So like I said, I'm just passing in those two. These are just two angles. Like the current angle of the pixel, is it between these two angles? If it is between those angles, I just want to color it and I want to animate it. If the current angle is greater than the used, use the base color, which colors it green. So if let's say, so ideally I pass in 0. If I pass in 0, this is all green. If I pass in like 0.2, well, let's say 0.5, then it's up here, like around here. So that means everything before it is black and everything after it stays green. Else, use color, which is black. So if the angle coming in, if the angle that we're drawing is greater than the angle of used, then it's green. So like I said, anything greater than the value I'm passing in is green. It's I consider not used. That's why I'm saying used. I'm kind of like going backwards when I'm dealing with angles. And then use rinse and repeat for each ring. Like I said, I built this to have hard-coded. You can build this, again, to have as many rings as you want. You can have like 10 rings, have an array that loops. And every ring is the exact same code. So that's really just the gist of the shader. So for the first thing, so if I'm asking for strength, I want to calculate the strength so I can pass this into the shader. Like I said, this is what's used, and this is the angle in which I want to show that blinking using animation. So if current is less than or equal to 0, that means I have full strength. It's all green. So there's no point calculating anything. I'm just gonna say the angle is it's all used up, and there's no angle for whatchamacallit for the blinking thing. Else, I'm going to say current times I unit strength. Technically, it's current divided by unit strength, but since I want to avoid division, I do an inverse of it. That's why I put an I. It doesn't mean integer. For me, it just means inverse of the unit strength. So I think I can do multiplication. We do this a lot lately with shaders. If the current value is greater than unit count, so return all zeros. That means no strength. That is going to show all black only. The idea is, the way I'm trying to, how the math works is, let's say the current state is 30. So I want to say, let's say, I don't know. Yeah, let's say 30. So I want to divide it by unit strength. So it's 10. That means it's 3. The value is 3. And that means there's 3 full units of stamina yet. And so I check to see there's a unit count, and unit count is 3. That's how many wheels we have. So that's why I say, well, if I divide it by 30 by 10, and I'm getting 3 full values left, 3 units full, that means we're full, or we're used up. Yeah, there's no strength. So that means I'm calculating how much is being used up currently. Sorry if I didn't explain that right. So that means we're using up 3 whole things. So if we used it all up, we're done for. Oh, wait a minute. I am so confused. This is like I'm looking at the comments. Like, no, all zeros means all zeros means no strength is being used. This one means all. Okay, all right. Sorry, I'm like long day. So yeah, like what I had before was right. So 30 divided by 10 means 3 full units. And that means we're good. So that means 0 angles. I want the angle 0 of how much I want to dim the wheel. So that means 0. So start drawing the green at 0, which 0 starts here. So 0 starts here, and 1 ends there. So that's where I want to start drawing the green part. I guess that's what you can count. Like, what is the angle to start drawing the green? If we are using strength, then we have to kind of calculate how much we're going to use. So we're going to calculate how much used and how much we're using. I forgot. I actually. Oh man, I forgot what some of this math does. All right. So what I'm doing is I'm checking backwards. That's one thing. So I'm going to check the outer ring into the lower ring. So I'm going to loop from unit count minus 2. So I'm checking between 2 and 0. Right? So if current, let's say, so let's see, if we have a value of 25 and we divide it by 10, that should give us a value, I guess, 2.5, right? So that we have a strength of 2.5. So we have 2 full wheels and we have half a third wheel. So if I'm looping between 2 and 0, because that's how many units we have, I check to see, is current greater than 2? So like I said, I'm working backwards. I'm working from 2 to 0. So the first time I find something that's bigger, we're done. We don't. That means that's currently the wheel that we're currently using. So I know it's 2.5, right? So I know it's 2.5. So that's my value. So then I'm going to subtract 1 from it, or actually no, subtract I from it, which is 2. Right? That gives me 0.5. This is the same thing as me saying fract in the shader code 2.5. That gives me 0.5. So nice little trick to use a fract. Just subtract it by the whole number. So like right here, that's where the line used. I'm just subtracting 2, the current index I'm doing. So this way I just get back the fraction. Because I'm going to use that as the percent or as the angle that I want to render everything at. I want the angle 0.5 between 0 and 1. And then I do an invert because that's how much we have left. But the way that I'm drawing, I want to draw how much has been used. So if let's just say for some other value I have 0.2, that's how much I have left, but I want to draw how much has been used. I subtract that from 1, and then I get a 0.8. 0.8. And that's what I pass into the shader as used. And then for using, I take that 0.2 and then I add the unit use, which is right here, 0.5. 0.5. So that gives me the other angle to draw. So between this and 0.8, I want to draw red. Anything less than 8, I want to draw green. And anything greater than 8, if I remember correctly, I might be doing this backwards. I want to draw black. So yeah, that's kind of like the math behind it. And I just say min of 1 because I don't want to go over a certain value. And if let's say current is, let's say 1.5 and we're currently checking 2, that means that 2 wheel or the third wheel is completely drained. So we say we drained it. It's completely drained. It's 1. And I have using default by 0. So I want to pass in, when it's completely drained, use this 1 and then using is 0. And we just pass it in. And then we just check to see we have an is full function. And that is really the gist of it. And then on render, I just check to see, am I currently running? Is the state equals ready? That means use it. And I say update state. And then I just pass the information to the shader. This is not a very efficient way of doing it, but whatever. It just illustrates it. If I'm not running, but the stamina is not full, I want to then do resting. And that means stamina has been updated, and that means draw it again. No, I mean, not draw it, just update all the information in the shader. So when it renders, it knows. And I have it right here, is heal. If the stamina equals exhausted, set 1. So this way I know I know to use the red color instead of green to highlight the whole row. Highlight the wheel. That how much strength is left in a wheel. And that is really the gist of it, really. And that's how you render it. And I have one more. We have our character. Let me go back to the shader. I feel like I didn't do a good job explaining this. I'm really sorry if I did a bad job explaining this. But at least you have all the source code, and I try to make it as simple as possible. I need to set back to 0 so it's transparent, so it looks good. I want it to look good when I use it. Got to clear the cache. There you go. So here, we have our character. He's running. He's walking. I press spacebar. Now he's all speedy. And when the stamina wheel runs, that's it. Now he's back to going slow again. Now he's out of stamina. Our little cube is all out of stamina. So if I'm still moving, I'm trying to press the spacebar. I can't re-heal. So I kind of built it as simply in a bad way that I need to stop moving for just a second, or for like 2 or 3 seconds, to allow it to heal, or to rejuvenate. So, and now we're back. And now we can go back fast again. There you go. And then we run out of stamina, we slow down again. And then you have to stop for a second. And every time I move, you're not resting. You're not completely rested. You have to be completely rested to be able to go fast again. So as long as I'm not completely exhausted, I can control my stamina. And I can let go. It'd be nice, like if you're not exhausted, you can easily heal when you're not moving. But like I said, this is just kind of a prototype. Yeah. So I think I made this video too long. But let's see. They have another test file called character control. I did like a really bad job of implementing it, by the way. And like I said, I kind of just shoehorned in. I put a lot of code that have the stamina. A lot of the code is still the same thing. If it's moving, if it's not full, we're gonna do a rest. Okay. I think everything is in the character controller. Quad position. When the character moves, I move the quad, which is the stamina wheel, so this makes it follow. So every time we do an update on our character controller, we move our stamina wheel along with it. What else do we have? And if we're moving and if we're not speeding up, whatever, if it's equal state, then we're using. If stamina is set up as exhausted, we're gonna force, even if we're pressing the spacebar button down or the A button on our gamepad, and we're trying to speed up, since the state is exhausted, we force it back down to 1, so we can't go fast again. So yeah, if we're moving and speed up is not 1, so like if the mouse button's being pressed, that means you're trying to speed up, and stamina is ready, then then it uses up stamina based on delta time. And I think I had to fix the character controller to kind of pass in delta time. That's the only thing I did. I shouldn't have to. Delta time does exist as a global variable in fungi. I don't know. Like I said, I didn't do a really good job of implementing. Like, this is kind of I just wanted to throw it in there just to show you guys that you can have this implemented with our character controller. Just an idea. Like I said, this is just a prototype. This is just most often you're probably here for the shader, and maybe just an example of how to do the math and how to render it. So yeah, so that's, like I said, there's not really much to it to implementation. Like, use this. Like, that's why I said the state exhausted is very useful, because this way I know you're completely out of stamina, and no matter how much you try, you can't go faster until you sit down, you rest, you wait 3 seconds, and then off you go. Back again. So, stamina wheel from Zelda. The end. Hopefully, this was fun to put together. I enjoyed playing with shaders to create the stamina wheel. It's kind of fun. So yeah, I don't know. Most people probably don't know that my goal right now, since I wanted to make an RPG game, is that now I want to make an open source. I want to make an open source game that has a lot of the same mechanics as Zelda, but I want to do a lot of things. But I would love to have a huge world that I can explore, climb everything, ideally, and I just like a lot of the mechanics, like stamina wheel, cooking, having tons of loot all over the place, things like that. So it might be like a year or 2 away, but hopefully at some point I'll be able to build enough pieces, like the stamina wheel, the character controller, that I can maybe build something small, web-based, and maybe do something desktop, and just actually build like a Zelda-like game with quests and stuff. Maybe a story mode, maybe not. Maybe just a big world to explore, find different areas. You know, kind of like Zelda-wise, I've been playing for a while, and I've barely done any story. I just exploring, finding all the weapons, figuring out how to kill. I still can't kill Lionels. I'm still kind of too weak. But I can kill Guardians fairly well now. Without killing myself all the time. So so yeah, that's kind of the end goal. It's kind of like a parody game of Zelda, but with combo books, anime, and everything kind of just thrown in. Like, I want to use the Scouter, like from Dragon Ball Z, in place of the Zika slate. So that might be kind of neat, you know. Since Zelda is very big on outfits, and outfits is really how you get strength and how you get defense, instead of, you know, like a normal RPG where you can kind of upgrade your character and you can upgrade your armor. So it's kind of funny, like, really most of the upgrades for your character is really based on clothing. I was thinking like One Punch Man. If you manage to find all the pieces of his outfit, you get the ability of not killing every character in the game with one punch. How sick would that be? In an RPG game, you just walk around and just punch. So yeah, like I said, I kind of like the mechanics of it. Like, if you're like I would like the game to be like a big old cosplay game, like an RPG cosplay game. And when you wear an outfit, you get that ability of the character. If you have that weapon has that ability that the characters kind of it came from. So I want a big old Zelda parody type of game. That's the goal, and I want it to be open source and free. And like the idea is like I want it to be moddable so people can do things with. My friends, we wasted too much time for the hopes or dreams of this little wannabe indie developer. So for now, I'm just making cubes run in this little environment. But we've gone pretty far in the last year. We got a world, we got stamina wheels, and we got cubes running. You got to count for progress, right? Maybe by a year from now, I'll have a cube climbing a mountain. Maybe we will. Maybe a circle, a sphere, or something. All right. I got to get going soon. And so see you guys in the next video. If you have any suggestions, like I want to build more pieces of Zelda. I'm working on something else. If you check Twitter, you'll see. So yeah, I'm just going on and just trying to build pieces for games and teach you guys all the pieces to how it all glues together and build up a game engine. So see you guys in the next video. Like and subscribe, and yeah, see ya.